When solving rational expressions, we have to remember to follow the 3 steps. And some of you may have come to this conclusion yourself. Not everybody does, so I always like to write it out. So first, we factor both the numerator and denominator. Second thing we do is find non-permissible values. The third thing we do is divide like factors. Now, why do we have to find non-permissible values before we divide like factors? Well, if we look back to our earlier example, I had to go back to the step where it was minus n and 2n minus 5 in order to find my non-permissible values, because those are all the factors in the denominator. When it was simplified, it wasn't showing me all of the factors in the denominator because we had canceled out or divided out like factors. So you have to do it before you do the dividing of factors from the numerator and denominator. And you cannot do it until after you factored both the numerator and the denominator, because you need the factored form in order to find non-permissible values. So let's look at quite a complicated looking example. So example number 1, I have here x squared minus x all squared minus 8 times x squared minus x plus 12, all divided by x squared minus 4, all squared, minus x minus 2, again, all squared. So when looking at this, it seems extremely complicated. And for a lot of you, it seems very intimidating. So the first thing I'm going to do, actually, is what we call a rewrite. Or, as I like to call it, substitution. And by doing this, I'm going to make my original equation look a little bit more simple so I can figure it out a little bit faster. So the first thing I'm going to do is I'm going to use what we call a let statement, and I'm going to let x squared minus x equal the letter a. Now, why am I using x squared minus x? Because that is what is inside the squared part. It's also in my minus 8. So I have some commonality there. So if I rewrite the original equation on the numerator with my a, it's going to be a squared minus 8a plus 12. Well, that looks so much simpler for me to now be able to factor, because that now looks like a quadratic that I'm used to. Let's look at the denominator. I have x squared minus 4 all squared, and then minus x minus 2 all squared. Okay, I'm going to have to look at separating those out into 2 different let statements. So I'm going to let x squared minus 4 equal b, and then I'm going to let x minus 2 equal c. Now let's put those into my denominator of my equation. That gives me b squared minus c squared. Again, now this looks more like something I know. So something squared minus something squared, well, that's a perfect square. And it looks like something I've been doing through the quadratics unit. A squared minus 8a plus 12, that looks like a regular quadratic that I can factor. So now I can factor my top and my bottom. So let's go ahead and factor the numerator and denominator. A squared minus 8a plus 12. Well, what multiplied together equals 12, but added together equals minus 8. A minus 6 times a plus 2. Whoops. I'll change that to a minus because I need an 8. A minus 2. Try to catch yourself if you make those simple errors. That is something that is quite common. Perfect squares, a little bit easier. We're going to have b minus c times b plus c, because that is the formula for perfect squares when we're factoring. Now that I've done the factoring of that, I can actually take my let statements and I can resubstitute those back in for my a, b, and c. So I'm going to take for a, x squared minus x. So x squared minus x and x squared minus x. So it was x squared minus x minus 6, x squared minus x minus 2. I'm doing it in different colors just so you can see. And then on the bottom we have x squared minus 4. And then I have x minus 2. And then I had it again, x squared minus 4. And then x minus 2. And of course, I had x squared minus 4. I had a minus. And then I had x squared minus 4 plus. So I just wrote it for that to make it simpler for you to see the logic of where I'm going. Now let's go ahead and group our like things together, simplify both the numerator and denominator. So I have x squared minus x minus 6 times x squared minus x minus 2. Well, those are two quadratics that I'll be able to factor. On the bottom I have x squared minus x. And I have minus 4, minus a minus 2, so that's minus 4 plus 2, so that gives me minus 2. Then I have x squared plus x. Minus 4 plus minus 2 gives me minus 6. Again, quadratic and a quadratic. So I can go ahead and factor each of those quadratics. I am not going to distribute and multiply them out and get x to the 4th, because that's going to defeat my purpose of dividing my like factors in the end. So instead I'm going to factor them out. I have x squared minus x minus 6. Well, that gives me x minus 3, x plus 2. And then the second one on the numerator is x squared minus x minus 2, x minus 2, x plus 1. My numerator, I have x squared minus x minus 2. Well, that's x minus 2, x plus 1. I see a commonality there. X squared plus x minus 6. So that gives me x plus 3, x minus 2. All right, so now I can go ahead and look at what's the same. So I have x minus 3, x plus 2. No, x minus 3, x plus 2. Let's look at x minus 2, x plus 1. Well, I have an x minus 2, x plus 1, so I'm going to cancel those out. Yes, I have an extra x minus 2 here. One's already taken care of. There's nothing else to deal with. So my answer is going to be x minus 3, x plus 2, divided by x plus 3, x minus 2. Now it also asks for, if it asks you for the non-permissible values, you have to go to the spot before you divided your factors. Excuse me. And in this case, it was in this line here. That's where I've put all my factors. Yes, I've crossed out, but it was not my final solution after I've divided them all. So I'm going to go and I'm going to look at, okay, what do I have? I have an x minus 2 and an x minus 2. Well, I only have to put it once. So x equals 2. Do I have another one? Yes, I have x plus 1. X plus 1 equals 0. X equals negative 1. Do I have another one? Yes, I have x plus 3. Set that to 0, solve for x equals negative 3. So these are my non-permissible values. So that means x cannot equal minus 3, minus 1, and 2. So again, make sure you always go back to that line before you wrote down the divided factors of numerator and denominator to find your non-permissible values. Let's look at one more example. We have x squared plus 2 squared minus x plus 2 minus 20, all divided by x squared minus 9. Okay, my numerator is a perfect square. Squared, squared, easy enough for me to factor. So I'm going to go ahead and do that. So it's x plus 3, x minus 3. My numerator, unfortunately, looks a little more complicated. I have an x plus 2 squared minus x plus 2 again, minus 20. So I'm going to rely on my rewrite, or as I like to call it, substitution, and my let statements. So I'm going to let x plus 2 equal a. And again, this is so I can have an easier time visualizing what I'm looking at and to make it easier for me to solve and simplify this equation. So I have a squared minus a minus 20. Now if I go ahead and factor, because now I have a quadratic that is much simpler for me to factor. A squared minus a minus 20, well I know that what multiplied by 20 equals negative 1, or I should say what multiplied by what equals negative 20 equals negative 1 when they're added together. Well, I have a minus 5, a plus 4. And then I have x plus 3, x minus 3 on the bottom. Now, I can go in on the next line and re-substitute in my a value into each of these spots. So I'm going to put x plus 2 minus 5, and then I have x plus 2 plus 4. And my bottom is the same, x plus 3, x minus 3. So now I can go ahead and just simplify my numerator. So I have x minus 3 and x plus 6 all over x plus 3, x minus 3. And now I can do my dividing. So I have x minus 3 and x minus 3. Looks like that's the only things I'd be able to divide, so that leaves me with x plus 6 over x plus 3. Now for non-permissible values, which section do I have to go to? I'm going to go to the one right here. If I look, I have here and I have here. So I have x plus 3 equals 0, and I have x minus 3 equals to 0. Gives me x equals negative 3 and x equals positive 3. So those are my two non-permissible values. So that means x cannot equal positive or negative 3. And that's my answer.